Today's problem is a closed system undergoes two processes one after the other. First one is constant pressure process at a pressure of 5 bar from initial volume of 0.03 meter cube to 0.09 meter cube. It is followed by polytropic process, polytropic expansion process accordingly to PV raised to 1.3 is equal to C from 0.09 meter cube volume to 0.2 meter final volume. Sketch the two processes on PV diagram. And find first one find pressure after expansion, final pressure after expansion. Second, work done during each process, and net work done. Now this is the question. A closed system undergoes a two process one after the other. First is constant pressure process at pressure 5 bar from initial volume is 0.03 to 0.09. Now this is a PV diagram. Pressure and volume diagram. The first is constant pressure. This is the diagram line. Constant pressure 1 and 2 state. Volume they have given it. Volume V1 is equal to 0.03 and V2 is equal to 0.09. It is followed by a polytropic process. Now first is constant pressure. This is a list of the formula. For constant pressure, this is the diagram. Constant pressure, this is the diagram. For polytropic process, this is the diagram. For polytropic process, this will be the diagram. For polytropic process, this will be the diagram. From 2 to 3, polytropic process. Here P is equal to C. Here PV raised to N is equal to C. And expansion process according to the PV raised to 1.3 into C for 0.9 meter cube volume to 0.2 meter. This will be V3 is equal to 0.2 meter cube. This will be meter cube. This will be meter cube. Final volume. The two process. First is the constant pressure. Bar they have given it. Constant pressure P1 and P2 is equal to 5 bar. For the initial volume 0.03 and second 0.02. Followed by a polytropic process. This is the polytropic process. Expansion process according to P raised to 1.3 into C. From 0.92, this is the 0.9 to 0.2 meter cube. 0.2 meter cube. Sketch the two process on PV diagram. This part is completed. Next, find the final pressure after expansion. We need to find out the final pressure after expansion. Next, work done for each process and net work done we need to find out. Let us see. P1 is equal to P2, which is nothing but 5 bar, which can be written as 5 into 10 raised to 5 Pascal, 5 into 10 raised to 2 into 10 raised to 3, 5 into 10 raised to 2. Here 10 raised to 3 can be written as K. It will be kilopascal. Now first we need to find out the work done. We need to find out the work done with respect to constant pressure. We need to find out the work done. We know that W for 1 to 2, work done at constant pressure, the formula will be W or delta W, which is nothing but P into V2 minus V1. This is the formula for constant pressure. Work done for constant pressure, P into V2 minus V1. In order to find out the work done. Here P is nothing but P1 and P2. Substitute the value of P here, 5 into 10 raised to 2. The volume V2, here this is the volume V2, 0.09 minus V1 value, 0.03. If you calculate, the answer will be 5 into 10 raised to 2 into 0.09 minus 0.03. Close. Answer is 30. Kilojoule. Now we need to find out the next work done with respect to polytropic process. But we know P1 value, P2 value. We don't know P3 value. P3 is question mark. They are not given it. We need to find out. With respect to polytropic process. Polytropic expansion they have given it. Polytropic expansion. For polytropic process, this is the formula. PV raised to N is equal to C. Work done formula will be P1 V1 minus P2 V2 divided by N minus 1. Here we are going to write the work done formula in this form. P2 V2 minus P3 V3 divided by N minus 1. Because the state will be 2 and 3. Now we need to find out P3 value. We know the formula PV raised to n is equal to C. Based on this one we are going to find out. See here, P2 V2 raised to 1.3 is equal to P3 V3 raised to 1.3. We need to find out P3 value. It can be written as P2 V2 divided by V3 raised to 1.3 is equal to P3 is equal to P3 is equal to P3. Now substitute the values here. P2 we know, P2 and P1 are both are same. P1 and P2 are same. Substitute the value. 5 into 10 raised to 2. V2 value is 0.09 divided by V3 value is 0.2 raised to 1.3 is equal to P3. Therefore P3 is equal to 5 into 10 raised to 2 into open bracket 0.09 divided by 0.2 raised to 1.3. The answer is 177.07 kilopascal. The answer is 17707 kilopascal. We got the final pressure after expansion. This is the after expansion final pressure. We need to find out the work done with respect to polytropic process. The formula for work done with respect to polytropic process, delta W, or W is equal to 2,3, because we are referring at a state 2,3, is equal to P2 V2 minus P3 V3 divided by n minus 1. We know P2 value is 5 into 10 raised to 2. V2 value will be 0.09. P3 value is 177.07. V3 value is 0.2. This is the V3 value 0.2 divided by the n value is 1.3 minus 1. 5 into 10 raised to 2 into 0.09 minus 177.07 into 0.2 divided by 1.3 minus 1. If you calculate, the answer will be 31. Work done delta W, or W is equal to 2,3, 31.97 kilojoule. We need to find out the net work done. That means we have to add it. Net work done. Net work will be W12 plus W23. W12 is 30 plus 31.95. Answer is 61.95 kilojoule. Answer is plus 30. 61.95 kilojoule. This is the problem. See here, this problem contains two processes. First is constant pressure followed by the polytropic process. We need to find out the work done, and we need to find out the final pressure. Then again we have to find out the polytropic work done. Then finally we have to go for net work done. That means we have to add both. You will get the answer. Any doubt regarding this problem? ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಹೇಳಪ್ಪ.
No, sir.
Next problem. Determine the total work done by a gas system following expansion process as shown in figure. This is the figure they have given it. This PV diagram, this is a volume diagram, volume A, B, C. 50 bar, volume they have given it 0.2, 0.4, 0.8. The volume, let us consider as VA, VB and VC. Here PA is equal to PB. PC is a question mark. This is the diagram they have given the VTU exam for 10 marks. 10 marks. We need to find out the total work. Now AB is nothing but a constant pressure. And BC is nothing but polytropic process. They have given as V raised to 1, 1.3 is equal to C. They have given it. PV raised to 1.3 is equal to C. This is the data they have given it. Based on the data, we need to solve the net work. Now, given PA is equal to PB, which is nothing but 50 bar, 50 into 10 raised to 5 Pascal. We have to multiply into 10 raised to 5. Next, 50 into 10 raised to 2 into 10 raised to 3 Pascal is equal to 50 into 10 raised to 2, 10 raised to 3 becomes K, kilopascal. We need to find out the work done with respect to constant pressure. Work done, delta W, or W is equal to AB, which is nothing but P VB minus VA. This is the formula for constant pressure. Now P value is known. P is 50 into 10 raised to 2. VB will be 0.4. VA will be 0.2. If you calculate, the answer will be 1000 kilojoule. Next, we need to find out the work done with respect to polytropic process, but we need to find out PC value. Now, constant polytropic process, polytropic expansion. Now, we know that PV is equal to N is equal to C. Now here they are given as PB VB raised to 1.3 is equal to PC VC raised to 1.3. We need to find out PC value. PB bracket open, PB divided by PC raised to 1.3 is equal to PC. Now substitute the value. PB value is P is nothing but PA is equal to PB. PB is nothing but 50 into 10 raised to 2. 50 into 10 raised to 2 into VB value will 0.4 divided by VC value will be 0.8 raised to 1.3 PC. 50 into 10 raised to 2 into 0.4, 0.8 1.3 solve. It is PC is equal to 2030.63 kilopascal. 63 kilopascal. We got the PC value now. Now we can find out the work done with respect to polytropic process. The formula delta W or W is equal to BC PB VB minus PC BC divided by n minus 1. PB will be 50 into 10 raised to 2, VB 0.4, PC 2030.63 into 0.8 divided by n value will be here, n value will be 1.3. 1.3 minus 1. If we calculate, the answer will be 1251.65 kilojoule. Further, we need to find out the total work done. Total work done, we need to find out total work, which is nothing but work done with respect to constant pressure plus work done with respect to polytropic process. Add 1000 plus 1251.165 one barrel. Okay, 1251.65 1251.65. If you add, the answer will be 2251.65 kilojoule. Any doubt regarding this problem?
ಸರ್ ಇದು ಯೂನಿಟ್ಸು ಅವರು ಫಿಗರಲ್ಲಿ ಬರ್ತಿರ್ತಾರ
ಕೊಟ್ಟಿದ್ದಾರೆ.
ನಾವೇನು ಕನ್ವರ್ಟ್ ಮಾಡೋದೇನು ಬೇಡ,
ಏನು ಬೇಕಾಗಿಲ್ಲ.
ಓಕೆ ಸರ್.
See, this is the problem. They have given it for 10 marks. 50 bar. They have mentioned it.
Okay sir. ಅದೇ m cube ಕೊಟ್ಟಿದ್ದಾರೆ.
Volume they have given it 0.2, 0.4, 0.8.
Okay sir, thank you.
Okay. Next problem. A perfect gas is undergoing a process in which T is proportional to V raised to 2 divided by 5. Calculate the work done. By the gas in going from state 1 in which the pressure is 100 bar and volume is 4 meter cube, to the state 2 in which volume is 2 meter cube. Also calculate the final pressure. VTU problem, VTU Jan 2007 for 10 marks. It is a perfect gas undergoing a process in which T is proportional to V raised to 2 by 5. Calculate the work done by the gas from the state 1 to pressure of 100 bar and the volume 4 meter cube to the state 2 in which the volume is 2 meter cube. This is the PV diagram with respect to question explanation. PV, there are two states, state 1 and state 2. State 1 and state 2. This is about T proportional to V 2 by 5. State 1 and 2. The pressure is given. P1 is equal to 100 bar and volume is V1 is equal to 4 meter cube, to the state 2 in which the volume is V2 is equal to 2 meter cube. We have to calculate the final pressure. We need to find out the work done and also calculate the final pressure. This is the diagram with respect to the question. Perfect gas.
ಸರ್ ಇದು 1 2 1 ಕೆಳಗಡೆ ಬರ್ದ ಮೇಲೆ 2 ಬರ್ದಿದ್ದು ಏನು ರೀಸನ್ ಸರ್?
ವಾಲ್ಯೂಮ್ ಕಮ್ಮಿ ಇದೆಯಲ್ಲ, ವಾಲ್ಯೂಮ್ ಹತ್ರ ಕಮ್ಮಿ ಬರಬೇಕಿಲ್ಲ. ದ ವಾಲ್ಯೂಮ್ ಇಸ್ ಲಾರ್ಜರ್ 4, ಕಮ್ಮಿ ಇದ್ರೆ ಇಲ್ಲಿ ಬರ್ತಿದ್ದೀನಿ.
ಓಕೆ ಸರ್,
ಗೊತ್ತಾಯ್ತಾ? ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಕಮ್ಮಿ ಇದೆ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಜಾಸ್ತಿ ಇದೆ. therefore it is written as 4. here it is 2.
ಓಕೆ ಸರ್, ಅಂದ್ರೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಸ್ಟೇಟ್ 1 ಅಲ್ಲಿ 100 ಬಾರ್ಗೆ 4 ಬಾರ್ ಅಂತ ಹೇಳಿದ್ರಿಂದ
ನಾವು ಈ ತರ ಬರೀತಾ ಇದ್ದೀವಿ.
ಸಪೋಸ್ ಅವನೇನಾದ್ರೂ 6 ಬಾರ್ ಅಂತ ಹೇಳಿದ್ರೆ I should write 1 on the top and 2 on the bottom, sir.
Excellent, correct.
Okay, right, sir.
Also calculate the final pressure here. Now see here, P2 is unknown for us. We need to find out. Solution: P1 100 bar. We need to convert in terms of Pascal. Nothing but 100 into 10 raised to 5, 100 into 10 raised to 2 into 10 raised to 3, 100 into 10 raised to 2. This become K Pascal, kilopascal. Now volume is given. V1 is equal to 4 meter cube and V2 is given 2 meter cube. Volume. Next, the condition is given: T is proportional to V raised to 2 by 5. 2 by 5. Now see here, this can be written as in this form: T1 divided by T2 equal to V1 divided by V2 raised to 2 by 5. This can be written as T1 divided by T2 V1 divided by V2 raised to 2 by 5. Now by using general gas equation which is nothing but P1 V1 divided by T1 P2 V2 divided by T2. This is we call as a general gas equation. This is a general gas equation. P1 V1 divided by T1 is equal to P2 V2 divided by T2. Further, by using this general gas equation, we need to solve for P2 value. See here, T1 divided by T2, T1 divided by T2, it is brought here, P2 P1 divided by P2 V2. See here, P1 V1 divided by T1 is equal to P2 V2 divided by T2. We are bringing the T1 here. P1 V1 divided by P2 V2 T1 divided by T2 in this form. Okay, I am writing in this way. P1 V1 P2 V2 bring this side and T1 need to send here. It in this form, P1 V1 divided by P2 V2 is equal to T1 by T2. I am writing in this form. Now further, we know that T1 by T2 is nothing but V1 by V2. V1 divided by V2. 2 by 5 is written as 0.4. 2 by 5 is nothing but 0.4 is equal to P1 V1 divided by P2 V2. Next, P1 V1, see here. Now we can write this P1 V1 this side. Mathematically it can be written as P1 P2 is equal to V1 divided by V2 0.4 minus 1, because we are bringing this V1 by V2 this direction. Then we have to write minus 1. We have to write minus 1. P1 by P2 ಇಲ್ಲಿ ಫಿಕ್ಸ್ ಮಾಡಬೇಕು. V1 V2 ಈ ಸೈಡ್ ಬಂದರೆ -1 ಅಂತ ಬರೀತೀವಿ ಮೇಲೆ. Okay. Further, it can be written as P1 P2 V1 divided by V2 minus 0.6 minus 0.6 minus 0.6 minus 0.6. 0.4 minus 1 is minus 0.6. It is written here. Next, P1 P2, in order to remove this minus sign, we can write mathematically V2 divided by V1 0.6. Up and down ಮಾಡ್ತಾ ಇದ್ದೀನಿ in order to remove the negative sign. Okay, if we move V2 top and V1 bottom, this sign will becomes positive 0.6. Further, again this can be written as in this form. See here, P1 V1 0.6 is equal to P2 V2 0.6. Because we need to find out P2 value, P1 V1 divided by V2 0.6 is equal to P2. Now P1 value is 100 into 10 raised to 2. V1 value will be 4 divided by 2 raised to 0.6 is equal to P2. If you calculate, the answer will be 100 into 10 raised to 2 into 4 divided by 2 raised to 0.6 is equal to, answer is 15157.16 kilopascal. We got the P2 value. We can find out the work done. The work done 1 to 2 P1 V1 minus P2 V2 divided by n minus 1. Now P1 is 100 into 10 raised to 2 into V1 is 4 minus P2 is 1517.16 into 4 divided by n value will be 0.6. 0.6 minus 1. If you calculate, answer will be minus 24214.2 kilojoule.
ಸರ್ ಅಲ್ಲಿ V1 V2ಗೆ 244 ಹಾಕಿದ್ರಿ ಕರೆಕ್ಟಾ?
ಇಲ್ಲಿ ತಪ್ಪಾಯಿತು, ಒಂದು ನಿಮಿಷ. V2 ಎಲ್ಲಿದೆ? V2 it is 2. V2 is just 2. You will get answer minus 24214.2 kilojoule. ಇದು ಸ್ವಲ್ಪ ಸ್ಪೆಷಲ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ. ತುಂಬ ಎಕ್ಸಾಮ್ಸ್ ಒಳಗೆ ಕೇಳಿಬಿಟ್ಟಿದ್ದಾರೆ. ತುಂಬ ಎಕ್ಸಾಮ್ಸ್ ಒಳಗೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಕ್ಸಾಮ್ಸ್ ಒಳಗೆ ಇದೇ ಪ್ರಾಬ್ಲಮ್ ಜಾಸ್ತಿ ಕೇಳಿದೆ.
ಸರ್ ಇದರಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ಕೊಟ್ಟಿದ್ರಲ್ಲ?
ಇಲ್ಲ, ಡಯಾಗ್ರಾಮ್ ಕೊಟ್ಟಿಲ್ಲ. ಎಲ್ಲೂ ಡಯಾಗ್ರಾಮ್ ಕೊಟ್ಟಿಲ್ಲ. ಹಾಂ, 0.5 ಇದು ಬೇರೆನೆ. 0.5 ಇಲ್ಲಿ ಕೇಳಿದ್ದಾನೆ ನೋಡ್ರಿ. ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಮಾಸ್ ಕೇಳಿದ್ದಾನೆ, ಆ್ಯಡ್ ಮಾಡಿದ್ದಾನೆ. 0.5 ಪರ್ಫೆಕ್ಟ್ ಗ್ಯಾಸ್ ಅಂತ ಕೇಳಿದ್ದಾನೆ. ಮಾಸ್ ಅಂತ ಹಾಕಿದೆ, PV MRT ತಗೋಬೇಕು. ಓಕೆ, ಡನ್. ನೆಕ್ಸ್ಟ್ T raised to ಇದು ಕ್ವಶನ್ ತುಂಬ ರಿಪೀಟ್ ಆಗಿದೆ, ಸ್ವಲ್ಪ ನೋಡ್ಕೊಂಡ್ರಪ್ಪ. ಇಲ್ಲಿ ಅಂದರೆ ಸ್ಪೆಷಲ್ ಅಂದರೆ ಏನಾಗಿದ್ರೆ T is proportional to V raised to 2/5 ಅಂತ ಕೊಡ್ತಾನೆ. We need to solve that one.
ಸರ್ ಇಲ್ಲಿ ಜನರಲ್ ಗ್ಯಾಸ್ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ ನಾವು ಜನರಲ್ ಗ್ಯಾಸ್ ಈಕ್ವೇಶನ್ ಫಾರ್ಮುಲಾ ಹಾಕೋದು P2 ಮತ್ತೆ N ಕಂಡುಹಿಡಿಯಕ?
ಹೌದು. ಇಲ್ಲ, ಇದು ಜನರಲ್. ಇದು ಏನು ಮಾಡಿದ್ದಾನೆ ಅಂದರೆ ನಾರ್ಮಲ್ ನಾವು ರೆಫರ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಪ್ರೆಷರ್ ಮತ್ತು ವಾಲ್ಯೂಮ್ ಮಾತ್ರ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಇಲ್ಲಿ ತನಕ ನೋಡಿರ್ಬೋದು ನೀವು ಎಲ್ಲರೂ. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಜನರಲ್ ಗ್ಯಾಸ್ ಈಕ್ವೇಶನಿಗೆ ದ T ಹ್ಯಾಸ್ ಟು ಬಿ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ P and V.
ಓಕೆ,
ಅದಕ್ಕೋಸ್ಕರ ಜನರಲ್ ಗ್ಯಾಸ್ ಈಕ್ವೇಶನ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ ನಾವು. ಈ ಫಾರ್ಮಿಗೆ ತರಬೇಕು ನಾವು, P ಮತ್ತು V ಫಾರ್ಮ್ ಒಳಗೆ ತರಬೇಕು. ದೇರ್ಫೋರ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ದಿಸ್ ಜನರಲ್ ಗ್ಯಾಸ್ ಈಕ್ವೇಶನ್. ಗೊತ್ತಾಯ್ತಾ? ನಾವು ನಾರ್ಮಲಿ ಎಲ್ಲ P ಮತ್ತು V ಒಳಗೆ ತರ್ತಾ ಇದ್ದೀವಿ.
ಹಾಂ ಸರ್,
ಅದಕ್ಕೋಸ್ಕರ ಅದು ಮಾಡಿ. ಇಲ್ಲಿದೆ ನೋಡ್ರಿ, 10 ಮಾರ್ಕ್ಸಿಗೆ ಕೇಳಿದ್ದಾನೆ. ಅದು ಮೇ ಬಿ 2024 ಒಳಗೆ, 23-24 ಒಳಗೆ. ಅದಕ್ಕೆ ಇದು ಸ್ವಲ್ಪ ಸ್ಪೆಷಲ್ ಪ್ರಾಬ್ಲಮ್. ಇದು ಅಂದರೆ ನಾರ್ಮಲ್ ಪ್ಯಾಟರ್ನ್ ಫಾಲೋ ಮಾಡಲ್ಲ. ನಮ್ದು ನಾರ್ಮಲ್ ಏನಿದೆಯಲ್ಲ PV ಅಂತ ನಾರ್ಮಲ್ ಫಾಲೋ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಏನಾಗುತ್ತೆ, ಇದು ಗ್ಯಾಸ್ ಇಕ್ವೇಷನ್ ಎಕ್ಸ್ಟ್ರಾ ಒಂದು ಆ್ಯಡ್ ಆಗುತ್ತೆ. ಅದು ನಿಮ್ಮದು ಲಿಸ್ಟ್ ಆಫ್ ಫಾರ್ಮುಲಾ ಒಳಗೆ ಆ್ಯಡ್ ಮಾಡಿರಿ. ಇದು ಒಂದು ಲಿಸ್ಟ್ ಆಫ್ ಫಾರ್ಮುಲಾಸ್ ಒಳಗೆ ಈ ಪಾರ್ಟ್ ಒಂದು ಆ್ಯಡ್ ಮಾಡಿರಿ. ಗ್ಯಾಸ್ ಇಕ್ವೇಷನ್ ನಾನು ಮಾಡಿದ್ದೀನಿ. ಇಲ್ಲಿ ಗ್ಯಾಸ್ ಇಕ್ವೇಷನ್ದು ಪಿ ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟಿ ಇಸ್ ಈಕ್ವಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ತೊಗೊಂಡಿದ್ದೀನಿ. ಅದೇ ಇಲ್ಲಿ ಮಾಡಿದ್ದೀನಿ. ಬಿಕಾಸ್ ವಿ ನೀಡ್ ಟು
ನಾವು ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ವಿ. ನಾವು 0.4 ನ n ಅನ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ವಿ ಸರ್.
ಹಾಂ ಇಲ್ಲಿ ಬರುತ್ತೆ.
ಅಲ್ಲಿ 2/5 ಬಂತಲ್ಲ, ಅದನ್ನ n ಅಂತ ತಿಳ್ಕೊಂಡ್ಬಿಟ್ಟು.
ಇಲ್ಲ ಇಲ್ಲಿ ಈ ಫಾರ್ಮ್ ಒಳಗೆ ತರಬೇಕು, ಅವಾಗ n ಅಂತ ತಗೋಬೇಕು. ಅದಕ್ಕೆ ಇದು ಸ್ವಲ್ಪ ಸ್ಪೆಷಲ್ ಪ್ರಾಬ್ಲಮ್. ಅದು ಸ್ವಲ್ಪ ಡಿಫ್ರೆಂಟ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಅಂತಲೇ ಇದು ಲಾಸ್ಟಿಗೆ ಇಡ್ತಾ ಇದ್ದೀನಿ ಇದು ಪ್ರಾಬ್ಲಮ್ಸ್. ಓಕೆನಾ? ಅರ್ಥ ಆಗಿದೆಯಾ?
ಸರಿ.
ಇದು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿರಿ, ಯಾಕಂದರೆ ತುಂಬ ರೀಸೆಂಟ್ಲಿ ಕೇಳಿದ್ದಾನೆ. ತುಂಬ ರೀಸೆಂಟ್ಲಿ 23-24 ಒಳಗೆ ಕೇಳಿದ್ದಾನೆ. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. To a closed system, 150 kilojoule of work is done on it. If the initial volume is 0.6 meter cube and pressure of system varies as follows. P is equal to 8 minus 4V, where V is pressure in bar and V is volume in meter cube. Determine the final volume and pressure of the system. VTU July 2014 for 10 marks. For 10 marks. See here, in the normal explanation, this is nothing but system. Let us consider this as system. If the work is done on the system, we need to consider negative. If the heat is rejected, we need to consider negative. If the work is done away from the system, we have to consider as positive. The heat is added, we need to consider as a positive. Here, in a closed system, there is a closed system. Let us consider this a closed system. The work is done on it. Therefore, we have to consider negative. We have to consider as a negative, because this is a system. If we are performing the work on the system, we need to consider negative. And the heat rejected, we have to consider as a negative here. If heat will be added, it considers as a positive. If the work is performed outside the boundary, then we have to consider as a positive. Now here we have to consider
ನಾಲ್ಕು ಒಂದು ಶಾರ್ಟ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರ್ಬಿಡಿ ಸರ್, ಅದು ಬರ್ಕೊಂಡ್ಬಿಡ್ತೀವಿ.
ಏನಿಲ್ಲ, ಒಂದು ಸಿಸ್ಟಮ್ ಇಲ್ಲ ಇದು ಯಾಕೆ ನಿಮಗೆ ಕರೆಕ್ಟಾಗಿ ಡಿಟೇಲ್ ಆಗಿ ಹೇಳ್ತಾ ಇಲ್ಲ ಅಂದರೆ, ನಿಮಗೆ ಚಾಪ್ಟರ್ 2 ಒಳಗೆ ಫಸ್ಟ್ ಲಾ ಕ್ಲಿಯರ್ ಆಗಿ ಬರುತ್ತೆ. ಈಗ ನಿಮಗೆ ಅಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಇಲ್ಲ.
ಓಕೆ.
ಹಾಂ, ಯಾಕೆ ಇದು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ ಜನವರಿ 2024 ಒಳಗೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಕೇಳಿಬಿಟ್ಟಿದ್ದಾನೆ.
ಓಕೆ.
ಈ ಪ್ರಾಬ್ಲಮ್ ಹೆಂಗಿದೆ ಅಂದರೆ ಈ ಪ್ರಾಬ್ಲಮ್ ನಿಮಗೆ ಮಾಡ್ಯೂಲ್ 2 ಒಳಗೂ ಬರುತ್ತೆ, ಚಾಪ್ಟರ್ 1 ಒಳಗೂ ಬರುತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿರಿ ಕನ್ಫ್ಯೂಸ್ ಇಲ್ಲಿ ಬಂದಿದೆ ನೋಡಿರಿ ಪ್ರಾಬ್ಲಮ್. ಅದಕ್ಕೋಸ್ಕರ ನಿಮಗೆ ಚಾಪ್ಟರ್ ಮಾಡ್ಯೂಲ್ 2 ಯಾವಾಗ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತಿಲ್ಲ ಅಲ್ಲಿ ನಿಮಗೆ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಫಸ್ಟ್ ಲಾ ಕ್ಲಾರಿಟಿ ಬರುತ್ತೆ. ಅಲ್ಲಿ ಈಗ ಟೈಮ್ ಬಿಂಗಿಗೆ ಅಷ್ಟೇ ಅರ್ಥ ಮಾಡ್ಕೊರಿ ಈಗ ಅಷ್ಟೇ.
ಸರಿ ಸರ್.
ಯಾಕಂದರೆ ಈ ಪ್ರಾಬ್ಲಮ್ 2 ಚಾಪ್ಟರ್ ಒಳಗೆ ಬರುತ್ತೆ. ಓಕೆನಾ? Now see here, a closed system, 150 kilojoule work is done on it. Therefore, we have to consider W is equal to minus 150 kilojoule. The minus indicate the work is performed on the system. Negative sign work done on system is considered as a negative sign. And if the initial volume is 0.6, initial volume V1 is equal to 0.6 meter cube, and the pressure of the system varies from, this is the pressure which varies from 8 minus 4 V. It will be in terms of bar. It will be in terms of bar. You need to convert in terms of kilopascal. 8 4V into 10 raised to 5. 8 4V into 10 raised to 2 into 10 raised to 3 PA. 8 minus 4V into 10 raised to 2 kilopascal. And V is in terms of volume, meter cube. We need to determine the final volume and pressure of the system. We need to determine the final volume and the pressure of the system. Now see here, we know that the formula for work done, general formula for work done is equal to integration of 1 to 2 P into dV. This is the general formula. Now in place of P, we need to substitute this equation, integration 1 to 2, because we have to carry it between the state 1 and 2. Here I am going to consider this value in place of P, 8 minus 4V into dV into 100. This is nothing but 100. 8 minus 4V into 100 kilopascal. 100 kilopascal. We know that the work done is minus 50 minus 150 is equal to 100 is a constant, take outside 1 2 8 minus 4V dV. Now divide by 100 for simplification, divide by 100, then it becomes minus 1.5 divided by 100 is minus 150 divided by 100 is equal to 100 divided by 100 integration 1 to 2 8 minus 4V into dV. It becomes minus 1.5, it will be 1 integration of 1 to 2 8 minus 4V dV. Now further minus 1.5. Now integration, let us consider 8 outside, integration 1 to 2 1 dV minus 4 constant 1 to 2 V dV. Integration of 1 is nothing but general formula, integration of 1 dx is nothing but x. and integration of x dx can be written as x square by 2. Mathematical formula. Integration of 1 is nothing but x. Integration of x dx is nothing but x square by 2. X square by 2 minus
ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಒಂಚೂರು ಹೇಳ್ಬಿಡಿ ಸರ್.
ಇಲ್ಲಿನಾ
ಹಾಂ,
ಏನಿಲ್ಲ, ಇಲ್ಲಿ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಈ ಇಂಟಿಗ್ರೇಷನ್ ಒಳಗೆ ಹೋದರೆ 8 ಈಸ್ ಔಟ್ಸೈಡ್. ಇಲ್ಲಿ 1 ಅಂತ ತೋತೀನಿ ನಾನು. 1 minus 4 integration 1 to v. ಇಲ್ಲಿ 8 ಬಾಜು 1 ಅಂತ ಇದೆ. ಕನ್ಸಿಡರ್ ಆಸ್ ಎ 1 ಇಂಟಿಗ್ರೇಷನ್. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ?
ಅಲ್ಲ ಹಂಗಾರೆ ಮೊದಲನೇದು ಅದು ಆಲ್ಫಾ ಸ್ಕ್ರಾಚ್ ಮಾಡಿದ್ದೀರಾ ಸರ್? ಅದು ಅಲ್ಲೇನಾದರೂ ಬರ್ದಿದ್ದೀರಾ? -1.5 ಈಸ್ ಈಕ್ವಲ್ ಟು ಅದೇ 8. ಓಕೆ, 8
ಇಂಟಿಗ್ರೇಷನ್ 1 dv
1 dv minus 4
integration 1 to 2 v into dv.
ಸರಿ ಸರ್.
ಓಕೆನಾ? ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ 1 is nothing but x. Integration of x is nothing but x square by 2. X square by 2. X square by 2. Further it can be written as 8. Here dv is there. We have to write v 1 to 2 minus 4 v square 2 divided by 2 minus v1 square divided by 2. Okay na? v1 it can be written as, sorry, v can be written as v2 square divided by 2 minus v1 square divided by 2. ಇಲ್ಲಾಂದರೆ ಇನ್ನೊಂದ್ಸತಿ ಇದು ಮಾಡ್ತೀವಿ, ಒಂದು ನಿಮಿಷ. minus 1.5 8 for constant 1 we have to write x v raised to 1 by 2 minus 4 v divided by 2 1 to 2 1 to 2. Further simplification minus 1.5 8 v2 minus v1. Now this and this get cancelled. 4 ಮತ್ತೆ 2 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. minus 2 v2 minus v1. ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಹೇಳ್ರಿ
ಸರ್. ಇದು ಒಳಗಡೆ v ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ ಸರ್. v ಸ್ಕ್ವೇರ್ by 2.
v ಸ್ಕ್ವೇರ್ ಎಲ್ಲಿ ಬರುತ್ತೆ ಸ್ಕ್ವೇರ್
ಸರ್? v dv ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡಿದ್ರೆ ನಾವು v ಸ್ಕ್ವೇರ್ by 2 ಆಗುತ್ತಾನೆ ಸರ್.
ಹಾಂ, ಸಾರಿಪ್ಪ. Done. v2 square minus v1 square. Thank you for correction. Further minus 1.5 is equal to 8 v2. We know that v1 value is 0.6 minus v2 square minus v1 value is 0.6 square. Next further minus 1.5 8 v2 minus 8 into 0.6 will be 4.8 minus 2 v2 square minus plus, it becomes plus 0.72. Further minus 1.5 is equal to 8 v2. These two add and subtract, it becomes let us consider this minus 2 v2 square minus 4.08 minus 4.8 plus 0.72 is nothing but minus 4.08 minus 4.08. Next, rewriting it or bring this direction, then it becomes what? Bring this side, it becomes 2 v2 square minus 8 v2 plus 4.08 minus 1.5 is equal to 0. We are bringing this term here, this direction. Therefore, minus become plus, this plus becomes minus, and the minus becomes plus. Minus 1.5 is equal to 0. Further, 2 v2 square minus 8 v2 plus 4.08 minus 1.5 is 2.58 is equal to 0. Now, by using the calculator, we need to solve. Equation 5, 3 you have to select. The first value is 2 minus 8, 2.58. Now answer is V2, answer is 3.64, because it is a square, therefore the two values has to appear. Next is or 0.353 value. This is a meter cube. As per the volume, we have to select the smallest value. We have to select the smallest one. Select the smallest value. Select the smaller volume. Then after selecting the smallest value, we need to find out the pressure. The formula for P value will be, they are given it here. This is the P value. P value converted into kilopascal. 8 minus 4V into 100. We got the V2 value. Substitute here. 8 minus 4 into 0.353 into 100. If you calculate, the answer will be 658.8 kilopascal. This is the answer. ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಹೇಳ್ರಿ. ತುಂಬ ರೀಸೆಂಟ್ಲಿ ಕೇಳಿದ್ದಾನೆ ಕ್ವಶನ್ ಇದು, ಫಾರ್ 10 marks.
ಸೆಲೆಕ್ಟ್ ದಿ ಸ್ಮಾಲರ್ ವ್ಯಾಲ್ಯೂ ಅಂದ್ರೆ ಕ್ಯಾಲ್ಸಿ 2 ವ್ಯಾಲ್ಯೂ ಕೊಡುತ್ತಾ ಸರ್?
ಹಾಂ, 2 ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಇಲ್ಲಿ ನೋಡ್ರಿ, 2 values, 3.64, 0.35. If it is a cubic ಅಂತ ಇದ್ರೆ 3 ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ.
ಓಕೆ.
ಸ್ಕ್ವೇರ್ ಇದ್ರೆ 2 ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ವಿ ಹ್ಯಾವ್ ಟು ಸೆಲೆಕ್ಟ್ ದ ಸ್ಮಾಲೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ. ಇದು ಸ್ವಲ್ಪ ಸ್ಪೆಷಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ಇವತ್ತು ಮಾಡಿದ್ದು ತುಂಬ ಸ್ಪೆಷಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ಇದು ತುಂಬ ಯೂನಿಕ್ ಆಗಿದೆ, ಸ್ಪೆಷಲ್ ಇದೆ ಇದು.
ನೀವು ಕಂಡುಹಿಡಿದಿದ್ದು P2?
P2ನೇ. P2 ಇಲ್ಲ, P value, pressure. Only to find out P.
Okay, sir.
Final volume we need to find out V2. Then we have to find out P value.
Okay, sir.
ಇದು ಸ್ವಲ್ಪ ಸ್ಪೆಷಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ನಾಳೆನೂ ಮತ್ತೆ ಸ್ಪೆಷಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡ್ತೀನಿ ನಾನು. ಓಕೆನಾ? ಅರ್ಥ ಆಗಿದೆಯಾ?
ಆಯ್ತನಾ?